Hello, Geometry. It's Mr. Zabo. Welcome to Unit 2, where we are going to focus primarily on Chapter 3, but we will dive a little bit into Chapter 4 as well, and might actually take a look at a couple of sections throughout the book that we think should be in Chapter 3. So the main component of what we're talking about now is congruence, and specifically triangle congruence. So when we're talking about congruent triangles, the key idea is the fact that we have all pairs of corresponding parts are congruent. By corresponding, we mean they're in the same location within each triangle. And when we deal with congruent triangles, it means all parts are congruent, every angle and every segment. And that gives us 6 separate congruent statements. And we have to make sure that we look at 2 separate things when we're dealing with this. First, what are those corresponding parts? And to understand that, I am getting rid completely of those triangles. I don't want to see them because that's not what helps me understand the corresponding parts. What helps me understand corresponding parts is the congruent statement. It is very important that we pay attention to the statement and that we write our statements accurately. The corresponding angles must be written in the exact same location inside the congruent statement. Therefore, in this example, angle J corresponds to angle M, angle K corresponds to angle O, and angle L corresponds to angle N. So I can go ahead and write my congruent angles straight from this statement here. Angle J is going to be congruent to angle M. Angle K is congruent to angle O. And angle L is congruent to angle N. Now it might be beneficial to look at these. And once I can look at them, mark my diagram. Angle J is congruent to angle M. Angle K is congruent to angle O, and angle L is congruent to angle N. Notice I have different congruent marks for my congruent angles. You can't mark them the same, otherwise you're showing that they are all congruent to each other. From here, I can identify my congruent segments. Okay? The segment that connects J to K is congruent to the segment that connects M to O, because I can tell because J and M are congruent, K and O are congruent, I can make that statement here. Segment JK is congruent to segment MO. In my triangle congruence statement, JK is first and second, MO is first and second. So all of those are going to match. Corresponding parts match in your congruent statements. And then furthermore, we can say that segment JL is congruent to, that goes from 1 mark to 3, so 1 to 3 is MN, segment MN, and segment KL is congruent to segment ON. Make sure we include all of our angle symbols in our segment. So we have 6 congruent parts when we have congruent triangles. Okay? So in these examples here, I want us to recall that there are still vertical angles. And now we have this new idea that's called the reflexive property. The reflexive property states that a segment is congruent to itself. So these 2 triangles share that segment, segment AC. The triangles are congruent because they are a reflection. One is a reflection of the other over one segment. They share that segment, so it is congruent. In our proofs, we will go ahead and use that idea and state that segment AC is congruent to segment AC. And our reason is reflexive property, or just reflexive property. We're going to use that quite a bit in proofs. And vertical angles are still true. If you look up here, I have all 6 things congruent, but the vertical angles aren't marked congruent. It doesn't mean they're not. Okay? I have segment DO congruent to segment VO, segment CO congruent to segment IO, segment CD is congruent to segment IV, and then angle D, angle V, angle C, angle I. Well, these angles are also congruent. I'm going to have to put additional marks here. And we can now, one thing that I'll allow you to do is state angle numbers, but you have to write the number in your diagram. So if I call that angle 1 and that angle 2, I can state, well, I already stated angle COD, which is now angle 1, and angle IOV, which is now angle 2. I can state angle 1 is congruent to angle 2. I have to assume the vertical angles first, then they're congruent because vertical angles imply congruence. All right, so these first two problems here are set up to help you understand what represents congruence and what doesn't. So take a couple of seconds here and determine whether there's enough information. If there is, write a triangle congruence statement. If there's not, just write not enough info. If you finish that before we unpause here, then look at the bottom, I should say, and see, can we set up any information based on the congruent statement that we have here? All right, so there's a lot to unpack here. First of all, these first two triangles on the left, we can't conclude they're congruent. Even though angles are congruent, we don't have segments from one triangle congruent to segments from the other triangle. So we can't make any conclusion here. And in the second one, they are congruent because corresponding angles are congruent, corresponding sides are congruent. I have 6 different triangle congruent statements. All of them are accurate. You would only need to state one of them. This is what makes grading these a little bit challenging because all of you could have chosen different versions of these. The key is you have to have corresponding angles in the same spot in your congruent statement. All right, and for the last part of this page, we have find the measures of the given angles or segments. Well, again, it comes down to understanding congruent statements. Measure of angle A equals x plus 10. The measure of angle D equals 2x. Well, A and D correspond. So these two must be equal. X plus 10 must equal 2x. So x is 10. And so if I know that x is 10, I know that the measure of angle A is 20 degrees. I know that the measure of angle D is also 20 degrees. They're equal. And if I know segment BC is 3x plus 2 and segment EF is x plus 6, well, segment BC is the second two vertices. Segment EF is the second two vertices. These must be equal. 3x plus 2 must equal this, so 2x must equal 4, and x is equal to 2. That tells me that segment BC is 8, and segment EF is also 8. All right, so now we're getting into really section 3.2, and that is, how do we use this in proofs? Do we need to show in a proof that all 6 parts of my triangle are congruent to prove they're congruent? And the answer is no. We only need to show 3 parts are congruent, and then we can conclude all 6 are congruent, or that the triangles are congruent. But it can't be any 3. Okay, so today we're going to learn about a few of these ways, and there are more than the 3 that we'll learn today. The first is, if I know that all 3 sides are congruent, then I can prove my triangles are congruent. So in this case, I know that segment AB is congruent to segment PQ, segment BC is congruent to segment QR, and segment AC is congruent to segment PR. Therefore, I can conclude triangle ABC is congruent to triangle PQR by side, side, side congruence. So formatting in a proof would look something like this. You'd have to have your 3 congruent statements. Then you can state your triangles are congruent by side, side, side congruence as your reason. Your reason for the 3 congruent statements would be either given or you've drawn that conclusion from other statements, such as midpoint or bisect, things like that. Okay? In a flow proof format, it would look more like this. You have to have 3 congruent parts and your congruent triangles. The next one is called angle side postulate. And in this case, it's not any angle. It has to be the angle that is formed by the 2 sides in the question. So The angle is formed by your two congruent sides. It is called the included angle. The included angle, that is the angle formed by your congruent sides. That is another way to show this. And so in this case, we would just call this side angle side congruence. And again, you would have to state your three congruent pieces, then you can state your triangles are congruent. The third and final one for today is angle side angle congruence. And again, it is called your included side, or angle side angle. It's your included side. So I have this angle and this angle. Those are my angle pairs, and it's the side that touches both angles. It is included in between those two angles. And we abbreviate this angle side angle congruence. And I would need to state my three congruent pieces before I can prove my triangles are congruent. Let's take a look at our first proof. Here's our first example. And there was no diagram, so now there is magically. So I have one given here. Segment FG is congruent to segment GH. And I have that GI, segment GI, bisects segment FH. Well, that's telling me that these two segments are congruent. Right now, I have two congruent statements. So this is going to allow me to conclude that segment FI is congruent to segment IH. I have two congruent statements, 1 and 2. I need a third before I can state my triangles are congruent. And this is where the idea that they share that side comes into play. I also can assume that they have GI as a congruent statement. The way we mark that on our diagram is with this little squiggle. If it's a vertical line, it looks like a little S. And I can state that segment GI is congruent to itself. There's my third congruent statement. Once I have three congruent parts, I can go ahead and prove my triangles are congruent. And so our proof would look something like this. I have congruent side given, bisect is given, that allowed me to conclude congruent sides, and then reflexive property. Now I can state my triangles are congruent. I am going to a lot of times mark my proof like this. I'll put a little S here and circle it. That's one side that's congruent. Here's a second side that's congruent. Here's a third side that is congruent. That allows me to confirm I have three congruent statements before my triangles are congruent, and I was able to identify what type. So that's the side congruence property. In example 2, again, we're missing our diagram, but it is the same diagram. And in fact, it winds up being almost the identical proof. It's just the fact that we have midpoint instead of bisect. So you can see the only difference in here is this given was different. Therefore, this reason part here was different. As long as my reason matches with the current given, it's almost the same proof. All right, and the last one today, angle A, I mark my diagram, is congruent to angle G, and segment AG is bisected by segment NR. So AG is getting cut in half. That means this segment's congruent to this segment. And then we have one more thing that we can do, and that is assume that our vertical angles here are congruent. So we're going to assume vertical angles, then they're congruent. I can see in my diagram now, I have an angle, I have a side, and an angle, the side is included. These are going to be congruent triangles. Take a minute, see if you can write out that proof. And here we go. We've got our givens, then segment AX congruent to segment XG, because bisecting implies two congruent segments. I've assumed my vertical angles, then they are congruent. I have my three congruent statements. If I don't have three congruent statements, I cannot prove the triangle is congruent. Now they're congruent by angle side angle congruence. All right, there are three problems that I want you guys to try. They are posted in ClassKick. Please try those three problems before class.